Hello and welcome to Sourav Sir's classes. Today we are discussing the subjective part of the ISI bstat paper. This is question number 2, where we are given that f is a function which satisfies this condition of f0 not equal to 0 and f1 equal to 0, and it satisfies the given equations for all integers x and y. So we have to determine the set of fa, and we have to prove that for fa not equal to 0 there is a set of numbers which is infinite. So first let us look at equation 2 or equation b and try to find out a recursive relationship from that. So if I substitute x equal to n plus 1 and y equal to n in the second equation, then I will get f of x minus y will become n plus 1 minus n, which is f of 1 into f of n plus 1 into f of n equals f of 0 times f of n plus 1 times f of n. So if I transpose all the terms to one side, I get f of 1 minus f of 0 times f of n plus 1 times f of n equal to 0. Now it is clearly given that f of 1 is not equal to f of 0. So therefore the first term cannot be 0. So therefore f of n multiplied by f of n plus 1 has to be equal to 0. So this means that out of any two consecutive terms, one of the terms has to be 0. So now if I put n equal to 0 in this equation, I get f of 0 into f of 1 equal to 0, and it is given that f of 0 is not 0, so the and f of 1 is 0, so this one is 0. Next I put n equal to 1, so I get f of 1 times f of 2 equal to 0. So f of 1 is 0, so f of 2 is not equal to 0. Next n equal to 2 will give me f of 2 into f of 3 equal to 0. So f of 2 is not equal to 0, so therefore f of 3 has to be 0. N equal to 3 will give me f of 3 times f of 4 equal to 0. Now f of 3 is 0, therefore f of 4 is not equal to 0, and so on. So this gives us a recursive relationship of each of the terms. So that means we can see from this sequence that f of 0 not equal to 0, f of 2 not equal to 0, f of 4 not equal to 0, and so on, and f of 1 equal to 0, f of 3 equal to 0, and so on. So that means f of any odd number will be equal to 0, and f of any even number will not be equal to 0. So that means we can clearly say that all the even terms f0, f2, f4, etc. will be equal to 0. Will be not equal to 0. All the odd terms f1, f3, etc. will be equal to 0. Now once again we use the same equation, f of x minus y minus f of 0 times f of x times f of y equal to 0, and we put x equal to 2, y equal to 0, and we get f of 2 minus f of 0 minus f of 0 times f of 2 times f of 0 equals 0, and we know that f of 0 is not equal to 0, f of 2 is not equal to 0, therefore f of 2 has to be equal to f of 0. Similarly, we can put other values of x, other even values of x, and we can prove that if I put x equal to 4, y equal to 0, I get the same condition. Then we can prove that f of 4 equal to f of 0, and so on. So that means this proves that all the even terms will be equal. So f0 will be equal to f2 will be equal to f4, and so on. Next, we will use the first equation, f of xy equals f of x plus f of y minus f of x times f of y, and we will put x equal to 2, y equal to 0 in that equation. So we will get f of 0 equals f of 2 plus f of 0 minus f of 2 times f of 0. So which means that I can cancel the terms f0 on both sides, so that will give me f of 2 into f0 minus 1 equals 0. Now f of 2 is not equal to 0, therefore this term has to be 0, or in other words f0 has to be 1. Now we have already proved that all the even terms will be equal, so therefore this will be equal to f2 equal to f4 equal to f6, and so on. So that means the series will look like f0 equal to 1, f1 equal to 0, f2 equal to 1, f3 equal to 0, f4 equal to 1, and so on. So 1 0 1 0 1 0 will be the series, and in that case this would be the series f of a, where a is an element of Z, and therefore there would be infinite number of terms which are not equal to 0, and these terms would be f of 0, f of 2, f of 4, etc. This will be the set which will be not equal to 0. So this is an infinite set.